Hello again, my name is Osman Abubakar. I am here to solve this problem. I want you to pay attention. Now there's a circle here with a chord AB, and there is a line drawn from the circumference of the circle to cut the chord AB at C. All right, and we are told to, as it were, find the radius of the circle, and we are given some dimensions, that is AB, which is 16 centimeters, and CD 4 centimeters. Now if you watch this problem closely, we can use two methods or two approaches to solve this problem. The first one, if you remember one of my lectures where I took you through the concept of intersecting chords theorem, if you remember that, we can use that approach to solve this problem. We can also use elementary geometry to solve this problem. Now let me call this method the first method. So I will say method of intersecting chords theorem, ICT, intersecting chords theorem. Now those of you who don't know this, you may want to check my lectures and go through the intersecting chords theorem. Okay, so I'm going to use that. Now if I'm going to use that, then I should be able to draw another chord, because this is the first chord. This is only a fraction of another chord, or the diameter. So I can extend this, I don't want to redraw the circle. So yeah, so I can extend this line to pass through the center of the circle to hit the circumference, so that I have another chord, and that chord is also the diameter, which is the major chord. Okay, so I'll put A, B, C, D, E. I'll put E here. All right, now if you remember the intersecting chords theorem very well, we can say that AC, so in fact we are solving, so solution. Okay, so AC, so AC times CB equals DC, so I'll say DC times CE. That is the intersecting chords theorem. You remember that clearly. Okay, so that now let's analyze the problem. We are told that AB is 16 centimeters. This is the AB, and then CD or DC is 4 centimeters. So I will put my 4 centimeters here. Now look at this. This means that AC equals CB, and of course it is true, because CD is perpendicular to AB, and it's a perpendicular bisector. It is dividing AB into two equal parts. Therefore, if AB is 16, then each half will be 8 centimeters. This 8 centimeters. Good. Now we know CD, we know AB, we know CB, but we don't know CE. Okay, now here is how it is done. The whole of this is the diameter, twice of a radii. Okay, so if the whole of this is a radius, we can say this is R. The whole of this is also a radius, we can say R. Therefore, the whole of DE is 2R. But CD or DC is 4 centimeters. So what will be CE? CE is going to be 2R minus 4. because the whole of this is 2r, but a fraction of it is 4 centimeters. What do we do to get the rest? We subtract this from the whole, and the whole is 2r. So this fraction is going to be 2r minus 4. Okay, now let's do the substitution. We know AC, so let me put the formula again. AC times CB equals DC times CE. All right, AC we know is 8 times CB is also 8 equals DC is 4 times CE is 2r minus 4. All right, so let's do some computations here. 8 times 8 is 64. All right, 64 equals, let's distribute. We are multiplying the 4 by the bracket, so this is going to multiply that. We are going to get 8r. This is going to multiply that. We are going to get minus 16 here. All right, so we are going to group like terms. 64, this is negative. When it crosses, it becomes positive, so plus 16 equals 8r. All right, this is going to give us is it 80? Yeah, we are going to get 80 here equals 8r. We are going to divide through by 8, so this 8 will delete that. 8 here 1, 8 here 10. Therefore r equals 10 centimeters, and r is the radius of the circle. Therefore the radius of this circle is 10 centimeters. This is the first method. Now follow me in my next lecture for the second method. Here again, my name is Osman Abubakar. Thank you. Bye bye.